This is video number 5 for sections 4.3 and 4.4, an exponential application. We're going to look at a lot more application problems later on in chapters 4 and 5. I just wanted to give you a little taste of where we're headed. So this particular problem is about the population of a town. We've got a bunch of people living in this town, and it says the population has been growing exponentially. In other words, it hasn't been growing linearly. If we drew a picture, it wouldn't look like a line. It would look like one of those exponential functions we've been working with. Well, here is our let statement. P is our dependent variable. P, or f of t, stands for the population, the people of the town. And t, the independent variable, stands for the number of years it's been since the year 2000. Here's an equation for the function, and if you look at it, you can see it fits that new pattern we've been working with, right? Y equals a times b to the x. The letters are different, but it fits the same pattern. It's an exponential function. All right, let's answer a couple of questions. The first question is, how many people live in the town today? Well, of course, it depends on when you're watching this video. I'm going to go ahead and use 2017 for today. Does that mean that I'm going to plug 2017 somewhere into this equation? Not at all, because remember, you got to go back to the let statement. It is a time, but t in this problem stands for how many years it's been since the year 2000. Well, 2017, that's 17 years later. So that's the t value I'm going to need to plug in, right? They're giving me a time, so I'm plugging in the t, and I'm looking for the people. I'm looking for the p. In other words, I'm really just being asked to calculate f of 17. Plug 17 in and work it out. The thing is, there's not really anything I can do by hand here. I'm going to have to just type this into the calculator. 200 times 1.078 to the 17. And it doesn't really say where to round, though since we're talking about people, it would probably make sense to just round to the nearest whole number. On my calculator, you should try it out on yours as well, but I got about 717. So if we're talking about the year 2017, we are saying that this little town would be up to 717 people. Obviously, if you were watching this in a different year, then you would use that year in order to work the calculation. Well, let's try the second question then. This one is kind of backwards. So now we're being asked to give a year. In what year will 2,200 people live in the town? We'd already got up to 717. Now we're trying to figure out when is it going to be that 2,200 people live in this town? Well, last time I plugged in a t and I figured out a p, a people. This is reverse. Now I have the people and I'm looking for the time. I'm looking for the t. So in my equation, I need to take that 2,200 and I need to replace the p. Well, let me go back to my let statement. The p, remember, is the same thing as f of t. So just go to your equation and replace the f of t with 2,200. Now I need to solve this equation for t, and here's where things get kind of interesting. I think you can tell pretty easily there's a simple algebra step. I'm trying to get t by itself. There's a simple algebra step I could do first, which is divide both sides by 200. That gives me 11 equals 1.078 to the t. But now I'm stuck. I'm looking at this thinking, how in the world am I going to get that t by itself? For one thing, it's up in the exponent position. It's not even on the main line. How in the world will I even get it down to the main line, let alone isolate it? Well, the thing is, we have no way to do that at this point. We have no algebra that we have learned that would allow us to do this. In fact, we're going to have to learn a whole new kind of algebra later on in Chapter 5. Until that time comes, the only way that we have to solve an equation like this is to rely on technology. So let me show you what you would do on the graphing calculator. Okay, so the first thing I need to do is I need to get a good picture of this function of our equation in the calculator. So I've gone to the y equals area. Remember, the calculator only uses x and y, so I will type in 200 times, I can just use parentheses for that, 1.078 to the, and I have to type x, right, instead of t. There's my equation typed in. I'm going to have to think a little bit about the window. I think if I used that zoom standard, it wouldn't work very well. Let's see. The x numbers in this problem are the years. I don't think I have negative time, so I think I'll just start at 0. As far as the maximum time, I'm not quite sure how far into the future I need to go. We went to 2017 earlier. What if I go to, I want to be safe. Let me go out, say, 40 years in the future. Okay, I may have to change that if it's not enough, and I'll count by tens. The y information in this problem was the people. Well, I don't have negative people, so I think 0 is a good starting point. And then the maximum, well, remember, we're trying to figure out something about when this population is 2,200. How about I go to 2,500 as a nice round number, and I will count by 500s. I feel like that's going to give me a decent picture. I can always adjust it if I need to. Let me hit graph. I'm expecting to see one of those nice exponential functions. And sure enough, it has that typical shape that we saw earlier. The x-axis is going to be an asymptote, right? I'm just not quite seeing that part of the graph. Well, the simplest way to answer the question we were trying to ask is just to use the trace button. Remember, we're trying to figure out the year that this population gets all the way up to 2,200. If I hit trace, I get a cursor on the graph. And this particular point is x equals 20. That would be the year 2020, right? 20 years after 2000. And my population is close to 900. Well, I think if I just start hitting that arrow, that right arrow, I'm going to start moving up that graph. And notice my population number keeps getting higher and higher. Well, I'm just going to click that until I get close to that 2,200 mark. This is not super accurate, but I think since we've been rounding our years to the nearest whole number, for now this is going to be good enough. I'm almost there. I'm almost to 2,000 people. Look, I just passed 2,000 people. I've gone over 30 years along here. I just got to get up to 2,200. Okay, that spot is a little below 2,200, and my x is 31.8. I think one spot further is a little bit above 2,200, and my x is 32.1. But either way, if you round those numbers off to the nearest whole number, you're getting 32, right? 31.8 or 32.1, both of those round off to x equals 32. If I really want to see where 32 takes me, if you hit trace again, you can actually type 32 and hit enter, and it'll take you right to that spot. And sure enough, we're right there around 2,200 people. So to answer our question, using the technology, we were not able to use algebra, but using the technology, we got a t-value of about 32. T stands for number of years since the year 2000, and so we're basically saying in the year 2032, that's when we expect that population to reach 2,200 people. When you are asked questions like this, until we learn that other fancy algebra stuff, the only thing you've got is this kind of technology approach.